Just trying to set. That's better. That should work. Trying to set something up so I can write some notes together before we. So I want to sort of talk about water treatment this evening. I haven't prepared anything whatsoever, other than stuff that various spreadsheets and other stuff that I've already got. So I figured we'll just sort of do it all and see how we go. But I wanted to sort of see, first of all, if there's any particular things that people wanted to ask or wanted specifically to know about. So I write down a list here and make sure we cover all of that. So yeah, has anybody got anything they wanted to ask or know about water treatment for brewing?
I think something that might be worth doing, you talked about earlier on about brewing the same beer and comparing them. Well, maybe we could brew this to the same recipe, but with different water treatments. See what that happens. See what. Obviously, this is going to be several months down the line, but that's something that's a possibility. Obviously, for the new chairman.
Yes. I'm trying to leave something in place for a new chairman, so they're not having to make it all up from the 1st of January. Yeah, start thinking about a new chairman, because we'll be doing the election towards the end of the year. Yeah, so is there anything people wanted to specifically know about water treatment, or can we just sort of brainstorm a few ideas as to what we should be talking about?
Go for it.
Sorry, I guess the only thing I would think about is possibly maybe the profiles for the different styles. I mean, I rely on a computer system grandfather and just take it as read as someone's done the background work, and therefore I'll work from that. But maybe there's a bit more knowledge that I need to be learning on that sort of thing.
Okay. And a couple other things.
I mean, RO systems are probably going to be on the list at some point in the discussion.
Yeah.
You should all start with testing too.
Well, testing, yeah, or getting water reports.
Yeah. Well, we'll sort of go through these, and I want to just compile a list of sort of reminder things to work through. We'll start from sort of the beginning and work our way through the process. Yes, just any other ideas? Acids. What else we got here?
Alkalinity.
Maybe the treatment at different stages of the brew.
Okay. Put that as there we go.
Is there something about faults as well? Because it can taste minerally, I guess, if you go a little bit too far.
Yep. Any other? What else we got in here?
Maybe some of the impacts of some of the things that you use. For example, calcium would be one of the factors maybe around why your beer doesn't clear.
Perhaps to go with the reverse osmosis, something about the actual water sources, whether it's tap water or whatever.
Okay. Excuse me, I've got my dog running around behind me. You spotted another dog outside. It's going a bit bananas.
Maybe something about where water plan fits with your development of a recipe.
Okay. I think it's quite a lot to start off with. Yeah, so I'm just going to leave this up on for a minute and talk away a little bit. So I thought actually it'd be good to sort of first of all just go around to everybody and sort of see, what do you do for water treatment? Do you have a particular way of doing it, bit of software you use, any particular testing gear, that sort of thing, just to see where, or do you not do anything? Be quite interesting. So for me, I've been a long way down the rabbit hole with water testing and treatment. I'm a bit more relaxed about it now, mainly because my house water supply hasn't changed in 9 years. Literally every time there's been an issue with something changed, I've realized it's a problem with the testing kit rather than the actual water supply. So yeah, it's not moved at all. So I'm fairly relaxed about doing it. So I do occasionally test it just to make sure. And then I treat with some acids. I use metabisulfite to remove chlorine, and then and treat with acids to reduce the carbonate in the water, and usually sometimes add a bit of calcium chloride or sulfate at the end to adjust the sort of final balance. So yeah, kind of how I go about it. In terms of how I calculate the amount, I've used a bit of brewing water, which is very complex. And then on the other hand, I've got my own spreadsheet, which kind of has my water source already in it and gives me a rough number as to when I put in the amount of water I want and the amount of alkalinity I want left in the water. It gives me a number of how much acid to put in. So it's sort of fairly straightforward.
When you say you occasionally test your water, Darren, what do you mean by that?
I use my alkalinity and alkalinity meter and a total dissolved solids meter. And if the numbers don't change on those, then I'm can be pretty certain that the water hasn't changed, given it's not changed in a long time. So yeah. And then I do have a pH meter as well, so I quite often check the mash pH, but again, it depends on what my brew day is going like. I don't always do it. So yeah, I do pretty much everything. So does anyone here not treat their water at all? No. Okay. Go on, Paul. Tell us about what you do.
No. It's a bit wide to say not treat the water. Yes, we all treat it for chlorines and chloramines, and we should do. But apart from that, I've recently started very small batch stovetop brewing, so 4.5 litres, and I haven't bothered to treat the water at all. And I've got Thames water here, so it's pretty high alkalinity, and I've been very pleased with the results. Yeah, so you might say, well, why do we bother? Why do we bother?
I tend to bother when it's dependent on the style. So if I mean, not made many of them, but if I do an IPA or Pilsner, then I will go back to basics and rip it right back to reverse osmosis, start from scratch, and then build it to the profile that I need. If I'm doing a mild or a dark beer, then I just don't bother and use the tap water as it stands. I mean, you're right. I've done the same in the sense of I've looked up the water reports that are available online for the area. I've looked at them for 2020 and 2021. They were fairly similar. And then recently, when we had the opportunity to come up on Slack to get the water tested, I did that as well. And indeed, that's lined up pretty much in line with the other two reports that I've got. So I'm now using that as my staple, as my water source in Grainfather. And I've got two different profiles, one for its tap water and one for reverse osmosis, and then just build whatever chemicals into the process that Grainfather tells me, dependent on the style I want to brew.
And how do you check what you're doing, Stuart?
The only real check I'm getting done would be pH. I don't have any other testing equipment yet. I do want to get a TDS meter just to keep an eye on my RO system. And just for, I mean, when I bought it from Malt Miller, I think when I read through all the pamphlets and everything else that came with it, it suggested it should be good for some 80,000 litres. So, you kind of think it's not going to fail anytime immediate, but it might be useful to get something in place to check it occasionally going forwards, that if it is starting to fail, I mean, it could fail for a different reason than it's gone past its life, I guess. But at least I'll have something there. And other than that, I need to investigate and find out more about the testing, really, to be able to satisfy that answer.
Yep. Cool.
I think
Thank
the
you.
answer to why do we do water treatment is probably quite a few of the things on the list already. Chlorine, chloramine, pH, alkalinity, possible faults or impacts of the ions. So it's a lot of the things that are on there are the reasons why we do it. The question is, I guess, can you tell the difference?
What do you do, Les?
Well, I use a blend of RO and tap water. I used to do testing with the Salifert kits for alkalinity and calcium. I don't do that now because I kind of know what it is, but I can tell when it changes because my mix of Star San is different. When they're using kind of reservoirs and surface water, it's almost clear. When they're using some of their aquifers, it's very milky and quite slimy. So actually my Star San is my kind of litmus paper about whether things have changed. But yeah, the treatments for chlorine, chloramine, blend of RO and tap water. And then I use, if I'm going to use acid, I don't have to use it very often, but it's probably only about 3 or 4 mil. And I do use calcium sulfate, chloride and sodium chloride.
I mean, the one thing there, well, that's where you would definitely benefit from having like a TDS meter, which are only a few pounds,
Yeah.
like a £5, because then you just put it in the water. Okay, that number's higher.
Yeah, I do have a TDS meter and a
Okay.
pH meter, so I don't use it very often, I have to say, but it's usually kind of when my Star San mix is different, and I think something's changed. And I'll go and get the meter out and have a look.
Okay, cool. Has anybody got any different ways of doing things? Any other tools that they use, that sort of thing? We'll sort of start walking through the process afterwards.
I mean, for the past few months, I've been.
Yeah, I've got active charcoal filter on the incoming supply, so I change that every 6 months. So it's that way I don't have to worry about adding Camden tablets, sodium met, etc. to your water. Although I mean, if you leave your hot liquor tank open it overnight, most of it is going to dissipate anyway. But yeah, I always run it through that, and I've done that probably for about 12 years now in total, I suppose, and never ever had a problem with any medicinal TCP type faults within your final beer. So
yep. Okay. Sorry, Arthur, you were saying as well, you got something?
Well, I'm saying, yeah, so for the past few months, I've been using spotless water. I've got one about 3-4 miles up the road from me. So, and then as I've been using the pure water for other things around the house anyway, and obviously Les makes a really good point about Star San and pure water. Obviously keeps it clear and nice for weeks. I'll literally keep a bucket just there, just full of Star San. So I've been using that, and it really is zero TDS. Is great. So then obviously using whatever salts I can build up, whatever profile that I want. My tap water's probably okay for brewing, but I'm just one of those people that just like a blank slate and just make anything, any profile going that I want, So invariably I make IPAs anyway, so they're often obviously sulfate, obviously over chloride, but yeah, and at 3.5 pence a litre, I think it is at the moment. You know, it's a couple of quid, 3 or 4 quid per brew day, and then I'll say I'll keep some from the stars then, and you know, the wife uses some as well for different things around the house. So it's just really useful.
Cool. Does anyone else use Spotless?
Yeah, I used it. I drive over, especially if I'm doing a check pills, to get it. Because I did, I think it's made a difference. It's made it like much smoother. All other things in my recipe being equal. I was going to say, Mick, the charcoal filter. I got one of those, like, drinking filter thingies next to the main tap. I think it does the same thing, but I can't find out what it filters out. It definitely tastes better, like in any case. And as far as I know, it's taking out some. Is it taking out chlorine? Is it just taking out like metal traces and stuff like that?
Any of those filters, it doesn't matter how small or how big they are, if they've got activated charcoal in there, they will strip out your chlorine and chloramine.
And the chloramine. Sorry, not chloramine,
Oh.
just chlorine.
You reckon?
Yeah. I
Well,
spoke with the guys.
Oh,
Damn it, the people who make my RO machine. I've forgotten their name for the moment, but they said no, you can't strip out chloramine with activated carbon. You have to
really?
use a special version of an activated charcoal filter that's very slow. It passes the water very slowly. Activated carbon won't remove chloramine. It does chlorine, but I don't think many water companies are using chloramine anyway at the minute.
They're not using chloramine.
They're not using. Not many are using chloramine.
Okay.
They are using chlorine, and that is removed by the carbon filter.
Yeah. Okay.
Chloramine is not removed by the carbon filter.
I think in general in the UK they're both used in sparing amounts to the point where you might be able to smell it in the tap water occasionally, and that is chloramine. But it's at such a low level that I don't think I've never had a beer where I think this has come through because of too much chlorine in the water. Maybe because you've left some bleach in your some part of your brewing system, but I don't think it's ever come across because of the water. But that doesn't mean it doesn't make a difference to removing it. It's one of those little things that might be sort of a 0.5% or a 1%, but obviously those things change over time.
I should
build
say
up
that
over
a
time.
bisulfate will remove chloramine. So if you're using that anyway, you've not got a
Yeah.
problem. Viair, that was the company I was talking about.
Okay. Yeah, so I just put on the screen. Actually, I've got a better one here. This is from the Window Cleaners Alliance that shows a map of Britain in sort of just showing the levels of hardness. Now, obviously, hardness is not really what we look at for brewing. We look at alkalinity. The main difference being that hardness is the measure of the amount of calcium and magnesium in your water, whereas alkalinity is a measure of carbonate and bicarbonate in your water. And carbonate and bicarbonate are the major buffers against pH change in the mash. And really, you want some hardness in your mash because you want calcium. You do want a little bit of magnesium for yeast health. So hardness is actually good. Alkalinity is bad. Is generally the way I put it. And the only difficulty is that because of the way that water tends to go through rocks and things like that, they come along together. So obviously water filters through, quite often through chalk or limestone, and picks up the calcium carbonate, dissolves it over decades or longer into the water, and then that's what you end up with. So you end up with both the calcium and the carbonate in your water in various forms. So what it means generally is where you get hard water, you get higher alkalinity. And here's a good map. So you can see most of the south and east of the country is hard. So anybody that says, "Oh, I can't brew with my water, it's hard as rocks here," that's bollocks, because people have been doing it for centuries. but equally Scotland, some parts of Wales and northwest of England have quite soft water, quite low alkalinity. I can certainly vouch for that. I've got my relatives which I'm regularly up in Manchester, and yes, their water is quite noticeably softer. They don't get any scale in their kettle and the like. So yeah, it'd be interesting if I ever decided to move up that way. Seeing as my wife's from up there, I might have to completely change the way I brew, at least on the water side of things. But yeah, I thought that was quite interesting. So I guess covered sort of the first bit really of chlorine and chloramine removal. Just a bit of a Camden tablet or a little bit of metabisulfite. That could be potassium metabisulfite or sodium metabisulfite. Yeah, just add a little bit in and the reaction works pretty quickly. So the second step for me for any water treatment would always be alkalinity reduction. Assuming you know what your alkalinity is, and I think first we're going to talk about covering testing. So on the testing side, we've talked a bit about TDS meters. Does anybody want to sort of give a quick overview of what that is, what it measures?
Which is conductivity. If you've got ions in the water, that changes the conductivity of the water, and that gives you a TDS reading. Yep,
I think they pretty much all, any meter that you stick in water pretty much measures conductivity in various ways, whether it's a pH meter or a TDS meter.
Does it matter that it doesn't break down which ions there are? Because it's a total measurement, isn't it? And mine's broken as well anyway. So, so I'm not getting another one for a minute. But does it have an impact what ions they are in what proportion, or does it just matter that there are loads or not many?
Anyone?
Do you mean? I think it's quite a simple setup. I mean, all it is, I think it is just literally measuring a voltage through the liquid. So I don't think I don't think what's in it makes any difference
to the flavour of the beer, because the ions are.
Oh no, well, it's just showing you overall stuff in it. I mean, pure water wouldn't, in theory, doesn't, if you see what I mean, doesn't have any ions in it, and therefore it won't work. So any stuff in that water, so it's only showing you sort of how many ions are in that water.
But is it important?
It's not very useful, honestly. TDS is total dissolved solids, so it could be anything.
Yeah,
that's what I'm getting.
The only thing it is useful for is, it might have been Arthur, I can't remember, somebody was talking about using it to check their RO machine. Because what you should have coming out of RO, especially if you've got a deionization stage at the end, you should have 0 parts per million TDS. The minute it goes to 1, the crystals are wearing out, or the membrane's starting to allow things through, and you need to do something about it. So that's kind of, for me, the only kind of use for TDS is to tell me that my RO system is in good condition.
Because I got one kind of in a little cheap package with a pH meter at one point, one of those things. You've probably all done that by the sound of it. And then kind of used it, and it was like, I don't know, sake of argument, 400 per million. I don't know, can't even remember the silly measurements now. But that kind of told me nothing, as we're kind of saying, because the water breakdown that I'm aiming at is almost very specific, and probably all sat there doing lots of little tweaks and measuring out 1,000th of a gram to make sure that you kind of hit the numbers, and then to find out that a TDS meter just lumps it all together, I kind of think, well, I wanted to know exactly how much. I'm going to pick not an ion now, am I? How much sulfates there are in it, or whatever. Shoot me down.
Well, yeah, I mean the TDS meter is kind of stupid. I mean it's a very basic thing. It is literally measuring conductivity. So this is like one I've got.
Mhm.
Was I think £4.50 off of eBay. So and when you look at it, it's got like two little metal wires sticking out of it, and it basically just measures the conductivity between them. It's nothing as sophisticated as a pH meter, and even that's measuring conductivity, but in a slightly different way.
I think as Les was saying though, they do have their purpose if you were
Yeah.
trying to measure purity of water.
Yeah.
I mean, that's sort of what they're for, is if you're after,
Right.
sort of water and you're trying to check it's pure, then that comes into its own. But it's not otherwise that useful.
But very useful to finding when to replace your RO membrane.
For me, there's two things. One is if you do have variability in the water or suspect you might, then it's a very quick check to say, am I on source A or source B or something else? Because you should know from the numbers, like source A, I'm just finding my brewing notes from the other week. So my tap water was 298 parts per million. So if I have some water in a nice GBBF glass,
It's a live test.
stick that in there, and the number says
It's
300.
not going to work. Not a live test.
No, it says 324. So a bit over. I might give that a test to see. But yeah,
how clean's the glass?
It's a good question. I memean, it's a very cheap meter. I'm going to test it again and see if anything changes. Nope, same reading. So, so it's that, and as Les said, is checking the RO is still coming through as RO. The one thing I would add to that is it depends what kind of RO system you have. If you've got a 4 or 5 stage one, then yes, you should be getting basically 0 coming out of it because it's producing you equivalent to distilled water. If you've only got 3 stage one, it will only reject something like 95 to 97% of dissolved solids. So you will be left with a little bit, but for brewing purposes, it's fine.
You just need to know what's normal for your system.
Yeah. I've only got a 3 stage one. And also if you have a 4 stage one and you those crystals change from orange or whatever it is to the other color, you can always just disconnect that bit because that's the final stage that takes your water down from sort of 95% pure to 99.9% pure. If you want to, and the membrane will keep going. So yeah, slight difference, but I've not had any issues myself with Starsan or anything else. And yeah, it's not distilled water, which this meter, if you put this in actual distilled water, it fails to recognize that it's in anything because it can't conduct anything through it. Yeah. Okay, yeah, so there's RO meters. What other testing? So you've got things like water reports. Obviously, you can get your municipal water report online. Again, mine's fairly stable. It should be fairly similar to what a lot of other people get. It's pretty accurate, having had the water tested by Phoenix Analytical. It's pretty close to that, and again, it's just for me an indicator of where things are. So for me, I've already said, like, if you've got an alkalinity test kit, so you know what that number is, you can pretty much guess what the level of calcium in your water is going to be, and then all the other numbers you can get from your water report normally, unless you're on like Les, where you're on different sources that are going to change over time. So yeah. Thinking what else we can do in terms of testing. Different alkalinity testing stuff. So people have mentioned the aquarium test kits, like the Salifert one. I used to use those. Does everybody, or do other people use those at the moment?
Only on occasion. I don't use it very much now because of the Starsan test is kind of my litmus paper now as to whether I need to do it again.
Mine doesn't seem to change that much, so I kind of do it every so often, and it's been exactly the same. So, but it's really useful. I mean, really useful test.
I know some other people use some slightly different tests. You sort of dropping little tablets into the water and things like that.
Yeah, there's a company that does what they call a Palin test kit.
Yeah.
And a long time ago, in the early days of lab, we had a group purchase because there's a quite high postage charge. If you just want to order one tiny little bottle of tablets with like 100 tablets in, they were charged about 10 quid postage or something stupid, So we had a large group purchase, and it sort of brought your postage charge right down. I bin mined when I started brewing again last year because the actual top of the plastic cap had cracked and it all got damp, and they were actually useless then. So I've just gone back to, I did Phoenix analysis. I also did a Murphy's test as well. I was quite surprised by some of the differences on some of the elements. So, but yeah, like most people said, water reports pretty similar, but although my Southern Water report down here has some basic emissions, so that's why I had to go and use a Murphy's or the Phoenix. So just to give you all those last few crucial bits of information to give you a full profile.
Yeah, I mean, if you can get alkalinity in parts per million of calcium carbonate,
yeah,
you can roughly guess calcium levels by it's about 0.4 of that value. It will get you close enough for brewing purposes anyway. It's not exact, but yeah, it's normally close enough. And then the other bits you can normally get from a water report. That virtually everyone has now chloride and sulfate on them, usually magnesium as well. Although I noticed a while ago on one report it said this, we're not obliged to give this, but we do because we're being pestered by home brewers.
It says that on my one as well.
Yeah. So yeah, that's sort of how you get to the basic numbers. Or you can go to someone like Murphy's, Multmiller sells their kits, or you buy a kit from them and they send you a vial, and then you send that to Murphy's, and then they send you a PDF water report. Or Phoenix, which is a bit cheaper.
Quite a bit cheaper, James. I was surprised. I checked on Multmiller the other day. I think the Murphy's one was about 60 quid, wasn't it?
Yeah, I think Phoenix is about 35.
Yeah,
used to be 25, I think. But so Neil is just Phoenix Analytical, stopped for a while, but started up again recently. So that's a good place to go, and he's very reliable and very thorough with it. So it's a good thing. If you want to go crazy with alkalinity testing, then you can buy one of these. But it doesn't really do anything more than what your Salifert aquarium test kit does. It's just slightly higher quality reagent that you put in it, and it basically you put a bit of water into a vial, and you stick that in this, and then press a button, and then it tells you to add some reagents. You add a bit of this, and it changes the color of the water, and then all this does is basically it looks at the light coming through that water and gives you a value based upon that. So it's just kind of a very fancy way of doing the aquarium test. It's more accurate than the Salifert, but I'd probably put that down more to the quality of reagent, which is considerably more expensive. This bottle is about so it's got 30 ml in it, so that's 30 tests, and cost about £12 on its own. The only thing I have found out recently, though, is that it does have an expiry date on it. And when you go significantly beyond that, the measurements start going wrong. Because I thought for a while I was getting very strange readings from it. And it turns out, yeah, it was just the reagent was old. So I had to go and buy a new thing of reagent. So that's just another way of doing it. What else have we got on the list here to discuss? So yeah, what's the software do people use software? Do they use a pen and pencil and slide rule, or how do people go about actually figuring out what they want in their water, things like that?
Well, I use brewing water. Had done for about 2 or 3 years. I think you said already that it's quite complicated, but if you actually mess around with it and change values and so on and see what it actually does when you change things is quite interesting. Putting in different base profiles of water and so on. So I've used that quite extensively. I just used the local water report, which down our way is pretty good. And again, I keep an eye on it, so and it's consistent. So yeah, I find brewing water, it is good, I think. It's pretty accurate, I found, for what goes on, when actually looking at it against other bits of brewing software for water.
Yeah, I know it used to struggle for me with the high level of alkalinity or high levels of stuff that was more at the extreme, so high alkalinity or high levels of like roastiness and things like that. But it's a lot better now. I think it's one of those things where there's theory and there's as to how the pH is adjusted by these things, and there's the actual reality is a bit different. The science doesn't quite line up with experience at the moment. So you might find in other software as well, the similar issues of the formula that's published only works in certain situations.
No, I have found that I had to adjust what I got out of that, say particularly on mash pH, of actually then using that as a guideline and then actually bothering to measure it myself and then adjust. I think that's probably the same for all of the software like that, though. It's from what I gather. I think even the person who made Brew and Water, there's a disclaimer about the fact that it's trying to get a sort of average of things, and you're trying to find one thing out from other things, and therefore it's complicated.
Yeah. Does anybody else use like the Grain Father or sort of Brew Father or anything like that?
Brewfather, yeah. Yeah, I use that. It's just easy. It's just quite a clean interface, and just using the up arrows, down arrows to the numbers I want to get. And it's just, it may not be as accurate as Brew and Water, but for ease of use, it's just easy.
Yeah, and I use the Grainfather one. Again, it's load up your water source, whether it's your RO profile or your tap water profile. It works off the 5 main stats and then just looks at those and looks at the style and says, right, in order to meet the style, you either need to add this or whatever, and gives you a profile of what to add in the mash water, and then gives you another profile of what to add in the liquor. In the sparge.
And for each of those, what are the options for sort of acids and things like that for when you've got higher levels of carbonate and things like that?
At the moment, I've only used lactic acid. I don't recall if it's got a drop down to put different types in. I think mine's just got lactic at 80%, which is what I have a bottle of in the loft in my chemicals kit anyway. So I'm happy, and I just work with that only.
Yeah, I use the Grainfather, and I use phosphoric, so it's got that option in there as well. And you can dial in whatever percentage of acid you've got.
Okay. So now Brew Father allows you to pretty much use anything, and as well as having a setting for CRS or AMS, which is more common. I don't think most people certainly the US don't use it. Never heard of it, but it's fairly common here, being provided by Murphy's. Yeah, I guess if the only thing I used to be wary of with lactic was that for the high level of carbonates in the water here, if you added the amount of lactic required to get down, particularly for pale ales, it was gonna, well, you'd be able to taste it in the finished product.
I came across that, James, actually exactly that, and I was having real trouble getting the measurements right in Brewfather, even though there was CRS was in that as well. So I did swap to CRS and found it much more accurate, and as I was much more able to hit the right mash pH without having that twang in the taste. It is noticeable. It's not horrible, but it's, you know what it is.
Occasionally pick it up in commercial beers as well.
Yeah, I've not done it, but I think in the States, a lot of people use phosphoric acid instead. And evidently that has a neutral contribution for the same kind of levels of alkalinity.
Again, like the only issue I've had with phosphoric when I used it was that the high level of calcium actually caused it to precipitate out in the kettle. So you'd actually like put it in there and it would just, you'd see this white stuff and sat in the bottom of the, or in the hot liquor tank. And it turned out it was calcium phosphate, I think.
Is were you adding sorry, you were adding the salts first and then then adding the phosphoric?
No, just the phosphoric into tap water.
Oh, into tap water, right.
And when it warmed up, so as it heated up, it just got this white precipitate in the bottom of it. It's like and it was mentioned to Martin Brewing Garden, the author of Brewing Water, and he said that's when there's too much calcium in the water. Now, I would say, like, from a British brewing background, you almost can't have too much calcium in the water, but yeah, so. But if you're using a mixture of RO and the like, it's probably going to be less of an issue.
Yeah,
If
it's
you're
a lot.
doing
I haven't noticed that because when I'm doing a lot of, say, pails, and I'm adding probably to a 25-litre brew. Well, with the mash and the sparge, probably 10 mils of or more of phosphoric to get my pH down to about 5.3, and I haven't noticed the precipitation.
What's the percentage strength of your phosphoric, Jerome?
88. I think it is, yeah, 88. Well, actually, tell a lie, I've just been corrected. 85. It's from APC or something, whoever they are. Yeah, so it's an 85. But then because I use brewing water, I can just tweak the percentage.
I'll see if I can find a picture of when it happened to me. So I did take a picture. It was quite curious, but yeah, so it's potentially an issue.
What would be that issue, James? If it's giving it, you end up with less calcium in your mash.
Well, if the calcium's sat at the bottom of my hot liquor tank, it's not where I want it in the beer, I think is the answer. So you don't know how much calcium you're going to end up with. I guess there's a small chance, well, you might end up with it scorching on the element or something like that. But
well, I found that because I use calcium chloride sort of lumps. Well, they're quite large, sort of 3 or 4 mils sometimes, clumps of it. I always put it in the night before and mix it in because I find that I have had problems with getting the salts to dissolve full stop. So I always put them in do my water the night before, but I always put my phosphoric acid in the last minute anyway.
Wouldn't
I've never. Sorry, go on, Craig.
Yeah, go ahead. I was just going to say, wouldn't the concern be that if you strip out some of the calcium, then you may not hit your mass pH correctly?
Yeah.
Yeah.
Yeah, I mean, I've always put any salts into I basically put them through the mill with my grain rather than into the hot liquor tank, just because I think that gypsum in particular doesn't always dissolve properly. But again, not sure about that. Right, what else haven't we discussed? So we talked about acids there. Chlorine, water, acid. So I think that's an interesting one of the impact of the different ions. So we've obviously got the 6 main ones are calcium, magnesium, sulfate, chloride, carbonate, and bicarbonate. And then there's a few other minor ones like nitrate and things like that, but they don't tend to really affect anything unless they're in very high amounts. what's different? What's people's sort of impressions of how each of those affects your beer, or what they're useful for? So what about like what's calcium in there for?
That's needed for lots of things, isn't it? Lots of the reactions that go on in the mash rely on the calcium. So there is quite a lot of stuff to do with calcium. The pH is determined by, in part, the levels of calcium. Some of the chemical enzymes that extract the starches are dependent on those calcium ions. The flavour and the mouthfeel of the beer is dependent on the calcium ions. So there's a lot going on with calcium, actually. Clarity of the beer is also another factor that can be impacted by the right or wrong level of calcium ions. It's a busy little ion.
Yeah, absolutely essential. Tends to be, for most beers, you want it 50 to 100 parts per million. You'll get some where it can go higher. So certainly some British beers will tend to be higher. And occasionally the sort of Czech Pilsners, things like that, will go lower than 50. But I think, generally the 50 to 100 parts per million is ideal. Does a lot for conversion, clarity in the final beer. And also, if you have too little of it, it can mean you end up with, I think it can contribute to beer stone as well. So yeah, you kind of want to generally get that at a reasonable level. I mean, you can brew with less of it, because barley and wheat also provide calcium. And as it provides a lot of the other ions as well in very high amounts. It's surprising, actually. I've seen some, I can't unfortunately share it on here because it's a commercial document, but I've got an interesting chart of where somebody went and tested lots and lots of beers globally to see the sort of differences between commercial beers brewed in different places. And I was gobsmacked at the level of ions in the sort of finished beer compared to what you would expect, to what we would start with normally. So yeah, there tends to be sort of whatever you think you put in, there's actually several times that in the finished beer usually. So yeah. So I guess the other one is the sort of sulfate and chloride. Is the other sort of big one that people tend to look at. Does anybody want to give a sort of overview as to what they provide, or what you believe they provide?
So
And if no one else wants to, Mark, we
Go on, Mark.
yeah, I mean, yeah, I guess it's the malt or the hops, whichever you want to shine mostly. So sulfite is the hops and chloride is the malt. Generally, is the sort of way I look at it. Apart from a New England IPA, which is in the reverse. That's my rule of thumb.
Les, what do you say?
Well, that's not a bad kind of summary, really. The sulfate is the gypsum that gives you a kind of more minerally dry, bitter. It accentuates bitterness, whereas the chloride. So did I say that was sulfate I was talking about there. Chloride is more about accentuating softness, sweetness, which kind of helps to bring out the malt. And as you say, the NEPA is the one that's kind of the wrong way around, because you are accentuating that kind of soft, full mouthfeel using the chloride, rather than the sulfate that you might have with a West Coast IPA or a dry beer.
Yep, so I can say from what Andy's given us for Oregon Trail, he says you want about 300 parts per million of sulfate and 100 of chloride in the beer. So you're loading up on sulfate to really dry the beer out. Whereas and to ignore all of the NEPA and hazy advice you get to go the other way. So yeah.
So if we put the Oregon Trail into beer smithing, we're aiming for a ratio of about 3 to 1 then, yeah?
Yep.
Yeah.
That's about right.
That's the other thing. Actually, the ratio of the sulfate and chloride ions is reported to be more of a factor than the numbers. So it's the ratio of those ions rather than the absolute numbers. I don't know what the limitations are on that, but that's supposed to be the case.
Sorry, he says it's 200 to 100 sulfate to chloride.
I thought 3 to 1 was a bit. Wow.
And he even used a bit of magnesium chloride to avoid pushing the calcium level too high. So, yeah.
I quite like using sodium chloride salt to give it a bit of extra body. And I always remember Andy telling us when we had that tasting of his beers, that's what he does. If you just want to a little bit more body mouthfeel to his beers, put the sodium chloride, put the salt in there.
That's right. The old guys in the pub used to sprinkle a bit of salt in their beer.
Yeah, I mean, if I'm doing stouts and stuff like that, I always put, let's say for a 40, 50 litre batch, I'll put maybe 5-6 grams of just regular table salt in.
So here's a thing for you, actually, for those of you that like coffee, try putting a couple of flakes of sodium chloride in your coffee cup. You'll spot the difference. Sorry, calcium chloride, not sodium chloride. Don't do that. Don't do that. Salty coffee is not what we're looking for.
Oh man, no, you go into coffee forums and things like that. That's like a whole different level of water treatment and stuff. You think brewers are crazy about it. It's people trying to get the perfect shot of espresso.
That's right. Yeah, but if you put some calcium chloride, not sodium, calcium chloride, a couple of flakes in your coffee, you'll tell the difference. It's a smoother coffee.
Yeah, and then obviously the other one's magnesium. Really, you only need a little bit for yeast health, and most of it comes from, or all that you ever need would come from malt if you're using all malt. Maybe slightly different if you're not using a malt, if you're sort of making a cider or something like that, potentially. Sodium, we just mentioned as well, which lends a bit of fullness. The magnesium, I believe it also it can add a bit of sharpness, to the point of tasting sour if you get high levels. And also if you get too high levels, it can have a bit of a laxative effect. Obviously what's in milk of magnesia. So yeah, let's be careful with that. You only need a small amount of it. And yeah, sodium, obviously, if you add too much, ends up a bit salty. Many years ago, we had the guys from Toast Brewery, which used bread in their beer. And they brought us a couple of samples of their early prototypes, which were salty, quite noticeably. And a couple of us made our own versions. And it was similar issue there, really, of I think they realized after that using, I think they now go back to about 25-30% bread in their mash, because any more than that, and you end up with quite a lot of salt in the brew overall.
I'll just ask a question about level of calcium. So I've got I did the Murphy's water treatment, so it gives you the per style what you should be adding, and then what you're kind of gonna supposedly end up with. So for example, ales, bitters, and IPA, so you add something like 25 ml of CRS and 13 grams of DWB, the Burton stuff. But the calcium ends up at 186 parts per million, and chloride is 200 and sulfate is 331. I always thought to get the alkalinity down, which it is down to like 23, that sounds like a huge amount of calcium. I wondered if that made any noticeable difference in general, or does it need to be much higher than that to make a difference? Because that's kind of double what the recommendation is.
Well, adding, so DWB is dry water Bertinization,
Yeah, I think it's
which is quite a lot of gypsum and a little bit of calcium chloride, I think, in it mainly. And then there's also
Yeah.
DLS, dry liquor salts, which might be the same thing, just under a different name.
I think so.
But they're basically just mixes of those, the sort of stuff you can buy on their own.
Yeah.
So you just go, we'll just add a heat teaspoon in or whatever, and I'm done. So yeah, I mean, I guess the only thing about those is that the salts on their own, I think, lower pH. Going off of what Brew and Water shows me, so they're raising hardness, but they're not affecting alkalinity because there's no bicarbonate with them. If that makes sense, Steve.
Yes.
So
Because
again,
the
hardness
alkalinity
is
drops.
calcium and magnesium. Alkalinity is carbonate and bicarbonate. They
Mhm.
tend to come together in water because of the way it's come through chalk,
Yeah.
which is calcium carbonate, and occasionally a bit of magnesium in there. But their alkalinity and hardness are different things, really.
Yeah. No, that's fine. I think I get that, I think. And it seems to work because the alkalinity drops from 215 to 23 with the measurements they've given. But you were talking about having the potential, what happens when you have calcium at too high a level. So that same addition that they recommend does sort the pH out, as I was mentioning earlier for the mash. It does work, but it doubles the calcium from 92 to 186. I just wondered if that, and my chloride goes 45 to 200, and sulfate goes from 45 to like 330. But it was the calcium that made me go, it seems like that's quite a lot. Or the overall amount of minerals, is that too minerally for a bitter? And I think an IPA is probably a British IPA anyway, isn't it? Not an American IPA.
You
Well,
might
I
come
think
to a point where it starts to taste more minerally, where you can actually taste that kind of flinty mineral bite.
So is that the only real thing? It doesn't affect the efficiency of the brewing process if the
I don't
calcium
think
is
so. I
too
don't think
high
so.
or anything? Oh, okay. I thought that was what we mentioned earlier. Or was it calcium was too low?
If the calcium's too low, that might affect the efficiency because you need calcium for some of those enzymic reactions.
Conversion. Yeah. Okay, thanks.
Yeah, I don't know whether there's another thing which the Brew and Water knowledge page mentions, which is sometimes adjusting the level of calcium should conform to the calcium content that the original yeast evolved to. So an English yeast might require high calcium content, whereas a Czech lager yeast might expect low calcium content.
Okay.
Maybe. It's kind of another way of looking at it.
I didn't realize we had princess yeast. Good grief. That's a new
Oh,
one
yeah.
on me.
Well, what if it makes sense? Like if you're just taking the water out of the ground and then you evolve your yeast to make the best beer, then yeah, maybe it does work out that way.
Got to match them together. Okay.
I don't suppose anyone's has the luxury of their own well water, do they? Probably not online. I don't know where anyone else in lab has their own well, and potentially, yeah, obviously you will only need to get that tested because you don't have the water companies to rely on with their analysis. But
Yeah, doesn't sound like anyone does.
okay, sink a borehole next week then.
So assuming you manage to use all your software and all your ions and everything like that, then I guess you get to the actual mash. So what are we aiming for in the mash? I've typically aimed between, I think in the past I've said 5.3 to 5.6. I'm sort of headed a bit lower than that these days, sort of 5.2 to 5.4. And that's measured at room temperature using this. So yeah, so I do have a pH meter to measure stuff with. It's quite a few years old now, and I occasionally have to buy a new probe at great expense. Yeah, but although they seem to last quite well if you buy good ones. So yeah, what do people aim for generally?
I often try and aim closer to 5.2 for the hoppier stuff, and they're fairly happy 5.4-ish, for bitters and other style stouts and stuff.
Same as, yeah, I'd go for 5.2 if I was doing a NEPA or something like that. I have found that pH meters are that's a whole subject in themselves, really.
Yeah, you can end up
Good
calibrating them for
ones,
days.
bad ones. How many times do you calibrate it? Yeah, as you say, room temperature. I think obviously again it's something that gets you in the ballpark and so on. Because I mean, all of this should be measured against what the beer tastes like at the end. So it doesn't really matter what brew and water says, stick this in to make that. Presumably, if it doesn't taste right, then it's, make your own mind up. And I think slightly with things like the measurements, go for what it tastes like, because it'll put you in the right ballpark, I think. But yeah, I mean, the thing about pH meters, I rely on mine because I know it's mine and I know its quirks, and that's quite an expensive one. But I'd probably calibrate it every time I use it, and every now and again something quirky will happen. But I mean, does everyone measure mash pH here? I assume, yeah, to some extent, rather, yeah. I mean, having said that, if you do the same brew time and time again, of course, you don't really need to. You can rely on your previous experience.
Yeah,
I'd
agree.
Test strips.
Oh, really?
Narrow range. You can get narrow range test strips, can't you?
Are they the test strips that go from sort of yellow to brown?
Well, I've got both. I've got one that's sort of yellow to sort of greeny blue color, and I've also got the yellow brown ones. And I've found the yellow and brown ones aren't that very, they're not accurate.
I always found like sticking that into a stout or something like that, I couldn't really tell the color that it came out.
You should shake it off, James. Yeah, maybe. I mean, that's why I've gone back to my sort of yellowy, greeny, blue ones. But they're getting a bit old now, so I don't know how accurate they still are. But there seems to be, on the pale beers, that they seem to be within probably a couple of points of the other ones.
I just started doing water chemistry with brewing water and making measurements, I think the last 2 batches. I bought a pH meter off of eBay or something and didn't spend very much. And having to wait for a sample for 15 minutes and then cool it down to room temperature and then make the measurement and find that it wasn't particularly in the range I was looking for. I think I didn't know quite what to do after 30 minutes had it been my first all grain batch, but I brewed for a long time without ever doing anything with water because I lived in places with really soft water and I didn't really have to worry very much. But I don't know, what do people do if you don't? I mean, one, how much do you have to spend to get a good pH meter that you can rely on? And 2 would be, what do you do if you miss your target pH and it's now a half an hour in or 20 minutes in because you've had to wait 15 minutes for it to equilibrate and then cool down to measure it?
No,
don't stress.
I wouldn't worry about it.
Make adjustments for the next one. You won't get bad beer.
Yeah.
Your pH can't be so bad that you get a bad beer. You might lose efficiency because the enzymes work best at a certain range. And if you're outside that range, they won't work as well. You will lose some efficiency.
Yeah.
So the beer might be a bit low on the alcohol. It might be a bit sweeter, depending on what you've done wrong. But generally, you'll still have a beer and make adjustments for the next brew.
Yeah, I think that the last 2 batches, maybe the meter is not good because my efficiency has been higher than it ever has been on the same equipment. So I don't, so I'm getting 80% plus efficiency batch sparging, which doesn't make any sense to me at all. But yeah,
the Hannah the Hannah Checker Plus, I think it's called, which is to 2 decimal places. I don't know. I think they're about 60 or 70 quid. They're a good one. I mean, Hannah, that's sort of what they make for pH meters, and that's what I use most of the time. I've got one of their more fancy ones, but that is pretty reliable. But yeah, I mean, I would agree. Don't sweat it. But
write it down, and then when you next brew the same beer,
I
maybe
mean,
adjust things.
that is important as well, because I used to measure my pH sort of 15 or so minutes into the mash to get my value. I've subsequently discovered that because the mash pH changes throughout, in fact, it's not a good time to measure it. The best time to measure your mash pH is at the end and put it down to experience. So there's nothing you can do for that brew, but just then the next brew and the next brew, you get there.
Yeah, I'd agree with that. I started chasing numbers by adding acid, and then it went the wrong way, and then putting bicarbonate in to bring it back. And oh God, what's the point?
Well, a couple of brews ago, I measured it every 10 minutes throughout a 75-minute mash. And it's an interesting graph, but it's, obviously it's a nice sloping graph or whatever that flattens out. But why people say check it at 15 minutes in on this idea that most of the conversion's done. Well, most of it's done, but there's still a lot to go after 15 minutes. So it's a bit of an arbitrary point to check your pH read. Well, I've always thought. You're better checking it at the end and then adjusting next time.
So yeah, when I got my pH meter, it was only about £30 or something, and the price of them has like trebled since then. But occasionally, when you look around, you'll find them cheaper. I've put a couple of links up there of eBay ones, which are where it's going for £40 or £56, and this is a pretty good meter. Compared to the little pen ones. The main thing about it is that when the probe goes, you can replace it. So it's useful. It's pretty easy to calibrate. But yeah, the other side of it, Jerome mentioned it a minute ago about like calibrating the thing. As like you spend ages calibrating it, and then if you try 2 different pH buffers, they're not always the same.
Well, the pH buffers go off. For instance, I keep mine in the fridge, but the pH 4, because it's presumably is a nice pH for some nice lactobacillus or whatever, tends to get a blackish growth in it. So even keeping it in the fridge, so you've got to chuck that away every 2 or 3 months, because otherwise, if your buffers are stuffed, then you might have a really good pH meter, but if your buffers are wrong, then it's going to be giving you all wrong readings.
Yeah, I've used these in the past, little packets that you mix into distilled water.
Yeah.
And I found actually if you use them and then chuck it, it's fine. But if you leave it, they drift.
Yeah, I use those, and they're cheap as anything from eBay, or AliExpress.
Very cheap, and were better than some commercial ones that I bought.
Yeah, and they'll make 250 ml up, whereas the little Hannah ones you get about 15 ml of the solution, which is enough for a test tube.
Yeah,
which
but
again,
I wouldn't keep them very long. After you made it up, I would tend to chuck it after a few weeks.
Does it drift that much? Because I've been doing like a pet bottle of each of those and then using them over a few months.
Well, I guess if you found that they've not drifted, as
wow.
The pH 7 sort of tends to keep forever, but it's around the pH 4. If you use a pH 4 buffer, that one goes off noticeably.
Yeah, I found my pH meter guesses what buffer it's using. If you keep the buffer solution, it goes, I think it might be the 9.1 or something.
On that one, if you're after a good pH meter, because it's all down to the probe, look on eBay and buy a decent bench one, or which hasn't got the probe with it. I mean, I bought one recently, or got one recently, and I think it was £8, and it was a £600 pH meter, but it didn't have the probe with it. Well, the probe's 150 quid, which then I bothered to spend that amount on a probe, but it's a top of the range one, but didn't have its probe with it. I mean, the eBay section of laboratory equipment, and you could always get a cheap Chinese probe, 20 quid.
I didn't get on with those very well. I ended up, because I did try those for a while, because the BNC probes, so like with this one, you can just twist it off and it.
Yeah.
So you can buy them for like £5 probe, pH probe replacements from eBay again, but I've had a couple of them and they didn't read at all accurately. And then I went back to bought a new one of these for quite a bit more. I think they're about £40, and was much better. So, and if you look after it, you keep it in the storage solution, they do last quite a long time.
I just use the cheap ones. I buy a
Just
handful.
don't stick it in hot water.
Yeah.
Just don't stick them in hot water.
No, I use the cheap ones, and when actually, usually I'm looking just for confirmation. I know what the pH is going to be because I repeat beers quite a lot. So if the reading is different, I assume it's the pH meter and chuck it away, get another one out. If that reads the same, I pick it back out the bin and sort out what's
Disposable
wrong with my
pH
brew.
meters. Brilliant. Yeah, so there's plenty of options on that. Yeah, so I'd say measure it at room temperature, write it down, fix it next time when you brew it again. And although mine reads again to 2 decimal places, I'd look at the first decimal place. Or maybe I go to like it's 5.35, but don't sweat it too much more than that. As long as it's not miles off, it's not going to make a big difference.
Just out of interest, does anyone measure the pH later on in the process and so on? And just as a quick aside, adjust the pH accordingly for the fermenter?
Not yet, but I'm thinking about doing it because again, with IPAs, you want like a knockout sort of about 5.0, 5.1, didn't you? So,
Yes.
or so I hear. And so yeah, so I've been testing it. I keep quite thorough logs because with pH. But yeah, one day soon.
Yeah, because I gather, particularly for sort of NEPAs and so on, you're getting brewers putting acid into the fermenter to drop the pH because of the idea that the hop addition is going to basically
raise the pH,
increase it.
Increase the pH.
I do it actually. So I use the CRS to get the mash pH right, and then if I'm doing the same brew time after time, then I kind of know what it should be at the end of the mash, about 5.2. Then maybe at the end of the boil, it should be like 5.1. And then once it's finished fermenting, I want it to be like sort of 4.4, something like that. So it's under 4.6, where it's below pathogen pH level, as it were. So I've kind of got used to dropping, so instead of using loads of lactic at the beginning, like I was mentioning earlier, just using it to adjust kind of as I go along. And I've kind of worked out roughly like 1 mil will drop 20 liters about 0.1. So you can usually work out if the pH says, X, and you're kind of 3 points out, then to add, you can kind of calculate how much to add, like 3 mil of lactic to make sure that your ferment finishes below 4.6 kind of thing. And then that helps with kind of clarity and shelf stability and crispness if it's a lager, for example.
Sour.
Or a sour, indeed, yeah. And also stops anything kind of tasting a bit kind of woolly or flabby. Sometimes it gives stuff a nice crispness, little click under things.
Yeah, it's odd you mentioned the using a mil per pH, or whatever, because I've noticed that if I was just trying to adjust pH within I don't know 5.3 to 5.2 or something, I could do that. I could either add a mil or take away a mil. but because pH isn't, it's logarithmic, isn't it? So in theory, to get to from 5.1 to 5.2, or as in 5.2 to 5.3, you're adding 10 times the amount that you would be to get, if you see what I mean. I mean, the pH scale, it's logarithmic. So to get from 5 to 4 is, and then from 4 to 3 is 10 times the amount it would be from 5 to 4 to 4 to 3. So you can't really use, like
1 mil
a mil like that.
0.1.
Yeah. Because I think if you're actually trying to buffer it, you've got to use a lot more.
Yeah, maybe it's to do with what buffering capacity is already in there, maybe. Yeah, no, you're quite right, actually. Of course, it's logarithmic, isn't it? Yeah, maybe it just seems to have worked with the brews that I regularly do, but it usually gets kind of enough down there. And I kind of do it once or twice during the thing as well. So during the boil, make sure it finishes it where it should, and then maybe like a mil or two in the fermenter just to make sure it gets below where it should be.
Right, so you're adding that into the fermenter. Yeah, at that stage,
yeah. So if it's missed a lot in the mash, then a little bit there, and it's really, you're actually quite right, it's really easy to overshoot as well. I've done that like so many times. So I've started doing it like little bit by little bit, like 2 mils in the mash, and then 2 mils in the boil, and then 2 mils in the fermenter, or something like that, until it's roughly where it's supposed to be ending up, kind of thing.
So do you measure your final pH in your beer, do you?
Yeah, when it goes into the fermenter, and then at bottling as well, I think, just to kind of, and during that as well, and it does creep up a little bit, but generally I try and get it to like 4.4, so it's stable and finger clicking good. That's for Les.
Cool. Yeah, I mean the pH is important in the boil as well for again for precipitation of proteins, things like that. So getting clarity, and obviously if you're brewing a sour beer, that will tend to be around 3.2 to 3.4. I think is normally where sour beers end up. I mean, I've measured it through the process before, and I think last time I did it, it was mash started off at this slightly higher, was at 5.6, dropped down to only dropped like 0.05 by the end of the mash. Oh, sorry, that's from 15 minutes through to the end of the mash, start the boil, and then it dropped 0.2, it's down to 5.4 into the fermenter after the boil. I think all those are probably a little bit high. But by the end of fermentation, it was 4.6. That was before dry hopping.
So on the brew date, you take samples all along and then just kind of set them out and let them cool, or do you try to force cool them to get I mean, if you're not going to do anything with the information, is it just kind of for the records, more or less?
For me, that one was kind of just to see what the values were through it. Normally, like Jerome was saying, I'd kind of take a sample 10, 15 minutes in or at the end of the mash, and yeah, just rapidly cool it for just so I can get on with measuring it, and check it then, just to see if I'm in the right ballpark.
I use, because when I use one of those little pH Hannah checkers, because the probe on that's not the same size as the standard sort of probes, I use a test tube. I have a little rack of test tubes. My sample is probably half full test tube. That it cools down really quickly. So, I mean, by the time I finish the brew, then it's down at room temperature, and I can take take the samples, they take the temperature then. If it was a problem, it would just be in a beaker of water that might have sat in the fridge for 10 minutes or something, and just with a little temperature with a thermometer, just check it until it's around 20, and then do that. And that's the good thing about using the test tube samples, is I also use those for doing my when I take the bricks readings, because I've with the refractometer I've got, I can just use a pipette and just drop samples out onto that. And it also helps because the test tubes allow the crud to clear it from the samples. It drops to the bottom, because I find that really affects refractometer readings. The amount of rubbish in the sample makes a lot of difference.
I found that by swirling the sample up once it's cooled down, you get obviously a bit more of an accurate reading. So does the sugar kind of stratify a bit?
No, what I find is, especially the earlier samples, when the water's not that clear, the amount of rubbish in it needs to settle out, and you get a completely different. This is going a little bit off topic, but this is for refractometer readings. They are much better if you let them settle out. I mean, some people filter it to remove the rubbish, because the refractometer, the way it works, doesn't like dissolved rubbish bits, and you get far more accurate readings later on in the process, because they're clearer just through the fact that you've been clearing the water.
I use empty goo dessert pots because it's got quite a wide base, and then they cool down quite quickly.
I'm a fan of the test tube.
He's a lab technician, so
well,
it's what I use.
Not a pudding eater. No, that's good. I do probably then make the mistake of swirling it up just so it's like a homogenized sample before.
Now, if I was going to take a refractometer reading, I'd let it settle out and take off the top with a pipette, one of those little disposable pipettes.
Yes,
which I wash out and reuse.
Yes, indeed. Same here. Okay, good tip.
Cool. So I guess then, kind of getting towards the end here, really. The only other things we had on here was sort of profiles for different styles. So we talked a little bit about it, sort of having the sulfate for hoppier, chloride for sort of maltier, I guess, softer kinds of things. Yeah, does anybody else want to sort of add to that? Is there anything else we can? Does everybody sort of just follow what it says in brewing water to your style or something like that?
If I'm doing a lager, I'll generally try go for a softer type profile. I'll try and hit my 50 calcium, and then just balance the other numbers, so it's quite even.
Yeah, I think that's sort of a fairly basic of sort of for me. With the sort of, if I'm making a bitter or a stout or something like that, I tend to largely sort of go with where my tap water is, and then just add a bit of calcium or a sort of bit of gypsum or calcium chloride to adjust the final balance. If I'm making a lager, I'll use a lot more or mostly RO and add that back in. And for sort of pale ales, things like that, bit of both. So I just have a moderate level of ions, not too much. Yeah, I don't know if it needs to be any more complicated than that, really. So I can't remember who asked for that originally. Is there anything anybody particularly wanted to know about it?
No, I think I mentioned at the beginning. I think it's just, I tend to follow the profiles given to me from Grainfather. I don't think my knowledge has expanded enough yet to have an understanding of the various different levels, and maybe that's where I need to sit down, get the book out, and do a bit more reading, as it were, just to have it. It's not something I'd have at my fingertips as a knowledge, just in my lack of knowledge, really, I guess.
Okay. Yeah, so I guess that kind of covers it all. Is there anything we haven't talked about? Anybody can think of? So it's been sort of a bit all over the place and the like, but yeah.
What acidulated malt? I don't know whether anybody bothers with that.
I can go on a rant about it if you want. So, like, acidulated malt is the German way of getting around the Reinheitsgebot, whereas everyone else in every other country in the world can just add acid to their water in the first place. That's my answer on it. It's like it's useful, but all it is either a malt that's been sprayed with lactic acid or it's had it cultured on it, and you chuck it in to adjust the mash because Germans aren't allowed to add acid to their water.
That's the case. They can doctor the ingredients going in, but you can't do anything else when you start the brew.
Exactly. You can grow any old stuff on your malt and put that into the mash, but you're not allowed to put it in directly. So
What do you
there you
think,
go.
Mark? Do you use it?
No, it was something I remember. I think Fraser gave a talk a while ago, and I think he said that he brought his pH down using acid, and then minutely adjusted in sort of 0.1 increments by using acidulated malt.
Yeah, he knows. Like he knew that on his system he could add like 100 grams of acid malt would adjust the pH by 0.1 or something. So he knew if he was out, and he would measure it like 10 minutes in, and if he's a bit over, he'd add some acid malt and adjust it then. And I was like, hey, he's an amazing brewer. Not gonna argue with it. So yeah, it's an answer to a problem that most people don't have.
Do yeasts have an effect at some point on the water? I mean, I had a conversation with Lukasz. I had that mango sour in the competition a little earlier in the year, which had a bit of a chloramine taste to it, and he suggested that the Philly sour yeast can amp that up big time. I don't know whether anyone's heard of any other yeasts that can amp up a specific element of the water.
Well, most of it comes from the malt, and then it's what I don't know how the acid or how the yeast then affects that. I'm sure it does. But yeah, there's just looking at a spreadsheet here of various beers and they're sort of testing commercially. I'll take a famous English ruby beer that's quite widely available in supermarkets and the like. It tested as having 111 parts. This in the finished beer had 111 parts per million of calcium, but also 86 parts per million of magnesium. And then most surprising was chloride, 450 parts per million, and sulfate, 133 parts per million. So yeah, the malt brings a lot more to the part. I can't believe they're putting that amount of chloride in the first place. And when you look at the rest of this, it's interesting reading.
What was that chloride against sulfate again there? Did you say 400 chloride or something?
Tested as 450 parts per million of chloride in the bottled beer.
And against sulfate or?
It was like 111 for sulfate. Most of the
expect
beers,
something
when
like that in a
tested,
Neva,
had.
but not a ruby beer.
Well, this is it. This is not the water going in. This is the finished beer. And an awful lot of them had a lot higher levels of chloride in the finished beer than you would normally expect. But yeah.
So is that down to what?
It comes from the malt.
Can only come from the malt.
Anyway, yeah. So what's finished in the finished beer is quite different to what's going in the first place. So I don't know how that really affects things. I've never quite understood it myself.
I
Yeah.
guess you are. I suppose whatever water the maltsters use must have an effect, and I'm guessing that's what you're saying, isn't it? Then.
I don't know.
Well,
Another
no,
one.
I mean, I assume this is stuff that's in the malt, which is then being made available. I mean, presumably some of these things they're either available or not, or whatever. So you're saying that if you measured the finished beer, it's got these levels of the salts and so on.
Yep.
But presumably they're released I don't know, throughout the fermentation process, possibly. So they're not going to be necessarily relevant in the, I don't know, the mash or even the boil or whatever.
Yeah. I don't know the exact method of it, but maybe we can talk about that a bit more after closing off the meeting for a minute. So if we've not got anything else, any other pressing things we wanted to discuss, then yeah, I'll call it there. So that's the end of the meeting. And we can just sort of chat away about anything else you want. So thank you very much for coming. I'll see you all back for the September meeting, which is when Ken is going to be presenting on Kolsch. And then hopefully lots of people will be brewing Kolsch over the winter. Yeah, we'll see you all then. So yeah, thank you guys.
Cheers, James.
Cheers.
Thank you.
James. Cheers,
All
James.
right. How do I stop this recording?